So what you guys would have primarily dealt with was arithmetic or linear series. Linear series going like 2, 5, 8, 11, 14, okay? You would have used the formula Tn equals A plus n minus 1 times D, where A is your starting off value and D is your gap. Very bargain basement questions, very easy. Okay. Now what you haven't done in a while, what you haven't done since probably Christmas was a quadratic sequence. So what it's going to ask you to do is it'll ask you to count how many matchsticks you have. You have 3 in the first one, then 1, 2, 3, 4, 5, 6, 7, 8. 8 in the second one, and then the third one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 3, 8, 15, okay? Very obvious that it's not a linear expression, right? Because the gap isn't the same. So what you do in a case like this is you do your first difference. Your first difference is going to be 3 to 5 is 5. Your second difference, 8 to 15 is 7. And now what is your second difference? 2. So you're expecting the next gap to be and 2 more than the previous one. 9. 9 plus 15, 24. Now if you were to draw this, my recommendation is that you just what is it? We have that is on a gap of 3, so the next one will be on a gap of 4, so you're going to have one, something like that, sort of halfway in between them all the time. So that one was 15, and now count 1, 2, 3, 4, 5, 6, 7, 8, 9. There's your extra 9. By adding that extra layer down the bottom, you're asked to draw the fourth diagram. You have 24. Now, can anybody tell me what the next one after that is going to contain? 35. Why is that? So 9 plus 2 is 11. There are 2 there. Makes that 35. So you know that sequence by that is 35. Explain why the sequence is quadratic. The sequence is quadratic because the second difference is consistent. Second difference is a consistent number. Find an expression for the nth term of the sequence. The nth term of the sequence, okay? It's what's called Tn. Now Tn is like the minus b formula. Remember you're given ax squared plus bx plus c. It's basically the same thing. It's not in your notes. An squared plus bn plus c. That's it there. Alright, now the thing is that your a value you can get straight away. Your a value is always half your second difference. What's the second difference? 2. So half of 2? 1. So it's just going to be 1n squared plus bn plus c. Now you still have to solve what b and c are. So you solve b and c by using a simultaneous equation. Okay? So t1, anybody? What's t1, the first term in your sequence? 3. And t2 was 8. T1 is 3, t2 is 8. So what I can do here is I can fill in this equation here. I can replace all the n's with 1's. So it's going to be 1 plus b plus c. That will equal 3. Bring the 1 over the other side. b plus c equals 2. Do the same thing for t2. Replace all n's with 2's. So 2 squared, 4, 2 times b plus c equals 8. Bring the 4 over the other side and you get 2b plus c equals 4. You now have a simultaneous equation. So what I recommend is you make the second one minuses and then add directly downwards to get b equals 2. And then substitute back in. We know that b plus c equals 2. 2 plus c equals 2. C therefore equals 0. Go back to the top and fill out your equation. It's going to be Tn is 1n squared, yeah, plus 2n plus nothing. Now, if you were to examine this in your calculator, and you know the table function that we're also fond of, well, exactly. Now, x squared plus 2x, start at 1, and I don't know, 10. Look what happens with the sequence of numbers we get. 1 3, 2 8, 3 15, 4 24, 5 35. What you notice about these numbers on the right hand side? They're the number of matchsticks in each term. So you can go back to the start and figure out how many matchsticks will be in. Example, use the n term to find the number of matchsticks in diagram 10. In diagram 10 it means just replace all the n's with 10. As it turns out I already have that done. There. 120. They could ask you a reverse question. I'll ask you the reverse question here. I'll do it for 8. Okay. What term will have 80 matchsticks? Do you understand? What term will have 80 matchsticks? So what you have to do is you have to say that your Tn equals 80, and then you're going to say n squared plus 2n equals 80. Then you're going to bring the 80 over to the other side, and what you're going to get is n squared plus 2n minus 80 equals 0. And then you can say n plus 10, n minus 8 equals 0. Why can n not be equal to minus 10? You can't have minus term, you can't have the minus 10 sequence. So the answer will have to be 8 as per our diagram here. Sean? So our first series is linear. How we explained a linear sequence was that we said that it's what we said about linear sequences is something like 2 4 6 8, yeah. Oh, sorry, 2 4 5 8 11. It's a linear sequence. It obeys the formula Tn equals a plus n minus 1 times d. The next type of sequence, if anybody can tell me this, 2 4 8 16 32. Geometric, or yeah, same thing as exponential, technically speaking. Okay, so formulas like this. The first one is Tn equals that, and our Sn formula for the other one, n over 2 into 2a plus n minus 1 times d. That's for linears. Okay, in quadratics, in geometrics, it's going to be. Anybody remember the geometric one?
It's 1 for n equal to n minus 1.
A r n minus 1. What's the a value? A value is 2. The r value is how much you multiply each one by. R equals 2. Okay, and in this one the a value is 2, but the d value is 3. And finally, your third type is your quadratic. Now, there's no Sn for quadratic, there's only Tn. Tn equals an squared plus bn plus c, where a equals half the second difference, and b and c have to be worked out using a simultaneous equation. Is that right? Okay.